All right, Algebra, and we are going to continue in this chapter 6. It feels like it's going on for a long, long time. And today might feel like a little bit of a break. We're not going to do a system of equations. We're getting ready for some of that. We're going to talk about linear inequalities. And to do that, we're going to start with just equations and review our graphing. First one is in slope-intercept form. Y equals mx plus b. So I'm going to use that positive 6. 1, 2, 3, 4, 5, 6. And then use my slope of negative 2 over 1 down to right 1, connect them, and that's all I have to do. Remember doing that? Okay, and let's grab our next one here. This one is in standard form, so I'm going to go ahead and solve this. 3x equals negative 15, divide by 3. X turns out to be negative 5, so 1, 2, 3, 4, 5. And as I solve the y, remember it's negative 5, y equals negative 15, divide by negative 5. So y turns out to be positive 3. So 1, 2, 3, and then we connect them, right? Standard form versus slope-intercept form. And you're like, wait a minute, we already did this. I'm like, true story. Tell it again, bro. Here we go. All right, so here's what we're going to do. We're going to change it around. Here's our slope-intercept form. I'm going to start with 5. This one's labeled, so it's a little bit faster. I'm going to use negative 2 over 1, down 2 over 1. All right, so here's the difference. It doesn't have an equal sign anymore. It has greater than or equal to. So what are we going to do with it? Since it has the equals to, I'm going to connect it with a solid line. Okay, so it's just like when you did a number line, right? Solid points on the number line, solid line here. Okay, whereas I like to shortcut that whole idea. If it has a solid line, then it gets a solid line. Notice number 2 over here will not be a solid line. It's going to be a dashed line. All right, but let's finish it out. The other thing we have to do is I have to test a point. So I'm going to highlight the easiest point in the whole world. It's the origin. So I'm going to plug in 0 for y and 0 for x. And I'm going to find out if this inequality is still true. So is 0 greater than 0 times negative 2 is 0. And 0 plus 5 is just 5. Is 0 greater than 5? No, that is totally false. So this point right here is false. So that means this side is false. And if this side is false, the other side must be true. So I'm going to put some shading on that side so we can see. All right. So the connection we're trying to make from a long time ago on the number line, right? Let's say this was 0. Let's say it was 5. Right? If you had this, it would be a solid circle, and you would shade one side or the other. Now we're going in 2 dimensions. Notice the y-axis is added on here. Okay. So let's try this again. In this problem, we're still going to start at 4. And we have 4. So I'm going to go 1, 2, 3, 4. So that's up here and over 1. All right. Now, take a look at that inequality. If this were on the number line, would it be open or closed? It would be an open circle, right? There's no equals to. So now it looks like a dashed line. To end it, it ends the same way. We're going to test 0, 0. Why do I keep using 0, 0? Because it's the easiest thing in the whole world to test. You can truly test any point that you want to. But if you do anything other than 0, 0, that's crazy talk. 0 times 4 is 0, plus 4 is 4. Is 0 less than 4? That's true. What's that mean? That means this blue highlighted area is true. So I'm going to shade all this stuff on the true side. All right. So if it has a solid line, it is a solid line. If it doesn't, it's a dashed line. And we're always going to test 0, 0 unless it goes through 0, 0. And then I got to pick something else. How's that for timing? Look at this one. It starts at 0. It goes through 0, 0. Oh, no. Now I can't use my favorite point in the whole world, but I will find the slope here, negative 4/5. So negative 4 and over 5. Solid or dashed, right? So this is kind of the thought process you want to go through. Y-intercept, slope, solid or dashed. This one happens to be dashed line. And it goes through 0, 0. So now you're like, all right, Mr. Toll, you told me to use 0, 0 because it's the easiest thing in the world. What am I supposed to do now? Remember, you can test anything you want. Here's my recommendation. This is only a recommendation, but I've been doing this for a long time, so I would follow my recommendation. Use 1, 1 if it's available. It happens to be available here. Why do I want you to use 1, 1? Because if I plug it in the wrong place, it really doesn't matter because I want to use doubles. All right, that's my point. Anytime you can, unless it is still on the line, use a double. All right, notice again, I'm highlighting, circling where I'm testing. So is 1 greater than negative 4/5? Well, that's true. And we always want the true side to be highlighted. or shaded. You know what I'm saying? All right, it's not too bad. It's not too bad. Okay, we got plus 1. Here we go, plus 1. The slope is negative 1 over 1. It has a solid line, so I'm going to draw a solid line. Whoop, there it is. I can go back to my 0, 0. So is 0 greater than or equal to negative 0 plus 1, negative 0. That's just 0. Is 0 greater than 1? No, cross it out. Shade the other side. Okie dokie. So we got to review something here, right? Because if we're graphing lines again, there's always something weird going on with this. Let's see. Hoy, 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 hoy. Y equals must be a horizontal line. So I need to find where y is 1. That's right here. And I'm going to put a horizontal line right through there. All right, now I'm not going to test it. Well, I could. All right, I can still test. I can test 0. So is 0 greater than 1? No, no. So we're going to shade the top. Okay. All right. So with these, right, so now that we know it's a horizontal line, y is greater than 1, right? Greater than it are the things above it, right? That makes more sense. When we talk about vertical and horizontal lines, we can deal with it just that way. All right. Next one we got negative 5. So here's negative 5. And we're going to go up 7 and over 3, 5, 6, 7 over 3. And right, again, solid or dashed. Dashed line, there it goes. And I'm going to test 0, 0. Where is it? Okay, so if you're getting confused, you're going to be like, are you showing where you're testing? So is 0 less than, all right, I'm tired of writing 7/3 times 0, right? You guys get the idea. This is going to get dropped every time. So is 0 less than negative 5? I'm going to clean that up. Is 0 less than negative 5? No, 0 happens to be greater than a negative number. So this is no good, and we'll shade over here, right? So since this is false, we're always going to shade the true side. Oh, say that 15 times fast. Good luck. All right, let's see. All right, I'm going to skip over a couple just because I want to get to standard form as well. All right. And we have to do this in reverse. What? Reverse? Yeah, reverse. All right. Y is negative y equals 5. So y equals negative 5. So y is negative 5. 3x equals 5 divided by 3. X is 1 2/3. 1 2/3. All right, so now we're in standard form. Again, I'm going to double check what's going on here. It has an equals to, so I'm going to connect those two with a solid line because it has a solid line. Where am I going to test it? I'm going to test it right here. In standard form, check this out, guys. 3 times 0 minus 0 greater than or equal to 5. So standard form, even better to check. The whole left-hand side, gone. Is 0 greater than 5? No. So that's no good. Where are we going to shade it? To the true side. Ooh, there it is. All right. Let's try it again. X is negative 2. X is negative 2. Y, 2y equals negative 2. Y divided by 2 turns out to be negative 1. Check it out. Dashed line. Test it right here at 0, 0. That means all this is gone. So is 0 less than negative 2? Is 0? No, 0 is greater. So this is false. So we're going to go to the other side, right? Shading the truth. We're going to bring out the truth here. Bringing out the truth. All right, let's try a couple more of these, and then we're going to do this in reverse. All right, 8x equals 4. Be careful, right? Divide by 8. This is 1/2. X is 1/2. All right. You couldn't imagine. I've been doing this for at least 100 years. How many times kids would tell me that's 2. Okay, so just make sure you set up your little equation as basic as it looks. It's going to get somebody. Don't let it be you. You know what I'm saying? We're too smart for that. All right. It has an equals to, so that means right, it has that solid line. So I'm going to connect them with a solid line, really steep downward line. And it gets really close to the origin, but it doesn't go through it, right? That means it's free to test. So 0 greater than 4. Is 0 greater than 4? No, that's false. No, thank you. Going to the other side. All right, always trying to bring out the best, bring out the truth in the matter. Yeah. All right, x is -9. Let's put that right about here. Y, -3y equals -9. Divide that by -3. Y turns out to be +3. That's raw hair. And no solid line, so no solid line, dash it up. Again, highlight. Here's where I'm going to test. Is 0 less than -9? Getting a lot of falses, right? So that's okay. So that's no good. So we go to the other side of the line. All right, so hopefully we have a pretty good handle of that because we're going to do this thing in reverse. 2 hops this time. All right, so we need to actually write it this time. So this is going to show if you completely 100% inside out, backwards and forwards understand what we're doing. Y-intercept is -3. Before that, I'm going to count the slope. Ready? So I'm going to go from here to here because that's a nice point. This point, it's an intercept, not a nice point, right? I'm looking for something that crosses right over the edge. So I'm going to go up 1, 2, and over 1. So the slope is 2. Now I have to figure out what goes in here. So remember, we kept testing 0, 0. Is this shaded? No, it's not, right? So here's what I have to do. I have to take 0 compared to -3 and make a false statement. So I know that 0 is actually greater than -3. So I'm going to say that it's less than. And then I'm going to check my line, and it looks like it's dashed, so I'm going to leave it just like that. Okay, so the fact that this was not shaded means I need to create a false statement. And we know that 0 should be greater than. All right, so let's do that again. So I got a y-intercept. This one is +3. In front of that should be a slope. We're going to go down 1, 2, and over 1, down 2, over 1. So I'm looking for this. Notice this time it is shaded. So I need a true statement out of 0. Right? This would turn into 0 and 3. What's true about 0 and 3? 3 is greater than. Okay, so I need to make sure this says less than, right? 0 is less than 3, 3 is greater than 0. Or as my younger children would tell you, it opens up to the greater one, right? So if we want this to be true, because 0, 0 is shaded, then that's what we need. And I check my line, and it looks like it's a solid line, so I'm going to add on that solid line. So this should be the inequality for that graph. All right, so that's how we deal with those in reverse. Looks like I got one more here, because this one, right, these are a little bit backwards, so it's okay if you're struggling a little bit, but let's get it figured out. So -3 in front of there, I got up 1. We're going to go over 1, 2, 3, 1/3. And again, I'm going off of 0, 0. This is not shaded, so I want a false statement about 0 and -3. Well, again, I know that 0 is greater than -3, so I'm going to say 0 is less than. And again, check the line. It is solid, so equals to. All right. Because of all these little details, look, guys, this is a huge thing for my students in particular, any students in Pennsylvania, the Keystone exam, right, standardized testing, because there's all these little details, right? Solid line, dash line, shaded above, shaded below, but it's on top of being able to graph a line, whether it's in standard form or slope intercept form. So this is a huge standardized testing area. So take your time, make sure you understand all the little details, and we'll keep working on that. If you're in my class, we'll keep working on it. If you're not in my class, just keep working on it until you got it.